Let's start with the most easy function for our indefinite integration. First example, if you're a beginner, it is better to integrate each term separately. And that will be 5 integral of x squared dx minus 2 integral of x dx plus for integral of dx. We will be using the general power formula of integration. Integral of the function u to the power of n times the derivative of u, which indicates the variable of integration. That is equals to u to the power of n plus 1 divided by n plus 1, then plus c. C is the constant of integration. In this other formula, integral of du is simply equals to u plus c. Now, let's start the integration, that is, copy the constant, 5, times x to the power of 2 plus 1, over to plus 1. Minus 2, times x squared over 2. Plus 4 times x. Then don't forget the constant of integration. We add c for every indefinite integration, because integrals serve as an inverse operation of differential. Since the differential of constant is 0, when we integrate a specific function, we have to assume that there might be a constant term in the original function before differentiation. So, let's move to the second example. The divisor is in third degree, and the dividend is degree of 2. Why do we have to investigate about this? It is because of the relationship of the function and the derivative of u in an integral formula. For example, in this formula, integral of du over u equals to natural logarithm of u plus c. Since the divisor has the higher degree, we will use this as our u. Then, the derivative must be 3x squared dx. If we compare this derivative to the given dividend, numerical coefficient of 3 is missing. Guanchana, we can modify this before the integration. Now, let's use the solve du, 3x squared dx, and over u, x cubed plus 4. Since we added a numerical coefficient of 3 on the right side of our integral sign, we must also add 1/3 at the left side of the sign. So basically, we just modified the function to satisfy the formula. As you can see, 1/3 times 3 is equals to 1, so it's like just the original function is multiplied by 1. Now, we can use the formula, copy, 1/3, then times ln of quantity of x cubed plus 4, plus c. And for our third example, since the divisor is in radical form, we cannot use the previous formula, but we can transform it into exponential form, and use the power formula of integration. U is must be equals to 3y squared plus 5, while n is equals to -1/2. Solve for the derivative of u, and that is 6y dy. Compare to the given, and it is needed to be modified. We use 6y dy as du. Let's multiply this by 1/6 and integrate. Copy 1/6, then do the power formula. And here's our answer. For the last example, by investigation, we cannot use the formula integral of du over u, since both dividend and divisor is to the degree of 1, but we can resolve the function into its partial fraction. And here's our answer. We will use integral of du for this one, and integral of du over u for this. Since derivative of u is the same, no need to modify the function. And here's our answer.